All right, well, welcome everyone to our brown bag session today, focused on monitoring and observability. My name is Lisa Carnes, and I'm one of the CSMs here at Sumo Logic. I'm going to get things kicked off here for us. So if you haven't been to one of our brown bag sessions before, we launched this series last April, and we provide them for our customers so that you can have an intimate setting with one of our subject matter experts to go over a technical topic. And so today's technical topic will be led by one of our technical account managers, Trent, who is a repeat presenter, by the way. Check out his other brown bags he's done in the past. He's done one on security, and I forget the other one you did, but you did awesome on both of those. So today he's going to be focusing on logs to metrics of Sumo Logic and Kubernetes observability. And so I have opened up the chat for everyone. So if you have any questions, please feel free to submit them in the chat, or you can use the Q&A. And so without further ado, I'll kick it over to Trent.
Awesome. Thank you so much, Lisa. Kind of diving into it, getting through the first couple slides or the introductory ones. I probably should have clicked through. So the agenda is going to be just kind of going over the general of what a metric is, kind of the metrics query UI. It's a little different than the logs. Continuing on to an overview of Kubernetes, what we offer in our app catalog, as well as how to use the metrics explorer and creating dashboards off of metrics, and then creating a monitor so you can kind of continue to monitor your Kubernetes environments. I would suggest for any deeper dive into what Kubernetes is and how we use it in Sumo Logic, I'd recommend spending some time in our learning environment at learn.sumologic.com. There are lots of stuff there. There you'll find ideal on-demand content for training for Kubernetes and using that data in Sumo Logic. As a quick, well, let's hope it'll be quick, intro to metrics. A metric is a set of data points that measures the value of something. Basically, metrics is the first and most critical domain in observability. Usually the first sign that something is wrong. When it comes to like logs, you kind of have to do a lot of digging to find it. You might see these kind of events later on, but a metric will actually present that data, the first sign that something does go wrong. Sumo customers use Sumo to collect metrics that can measure infrastructure, such as operating systems performance of disk activity, application performance, and custom business and operational data that is coded into the organization's applications. Metrics are an effective tool for monitoring and troubleshooting, and also identifying the root cause for problems. Metrics work better for regularly knowing predictable states for a system, for example, with alerts. Logs work better for researching unpredictable states of a system, for example, when you need to deeply investigate an incident. Logs can be unstructured, whereas metrics are structured. Example of how metrics can be used is gain end-to-end visibility into application performance, tracking KPIs over time, and determine if an outage has occurred and restored service. The structure of how metrics are built out. Metrics are numeric in nature and can be measured in dimensions. And dimensions are descriptive values or characteristics of your data. Sumo Logic automatically adds several metadata fields to metrics metadata in a number of ways. For instance, you can use metadata to scope your metrics queries. The way that we measure the metric as well is in data points per minute. The data points per minute, for example, if you are measuring CPU utilization for a host once every 10 seconds, then the one host metric combination will account for a rate of 6 data points per minute. Then you can go onto your account page and see how many data points per minute your account typically has if you're using metrics. Collecting metrics looks like madness, but it's quite easy. We do it with a lot of different collectors, different types, different ways. Through collectors and sources, you can ingest metrics into Sumo. These are the supported ways, and you do it through host metrics, Docker, stats, CloudWatch, AWS metadata tags, streaming metrics, Kubernetes, so on. The list can go on for a while. When you want to analyze your metrics, there are operators that we use that you don't normally see. Some of them will be new if you're not using metrics and you're used to using the logs. There's a link here that you can click on when the slide deck is shared out, and you'll be able to kind of dive into the operators and what each one does. The metric operators allow you to mathematical and logical operations to your metric data. We can spend time digging into each one if need be. But it just performs the query, it helps you query more complex analytics with these metrics operators.
Trent, is there like a more common one that you've seen, or they're all pretty important depending on what you're looking for?
The most common ones that I see and typically use would be average and sum, because when you're looking for making alerts or monitoring, you're typically looking for a count, so you can kind of build a monitor on that. So if a state changes enough times, then you can kind of get a count for that with sum, or an average as well, if you just kind of get a ballpark of it. You can use min-max for that as well and count, but those are the typical ones that I have used. Sorry, I wasn't looking at the Q&A. Thank you.
I got it.
The great thing about Sumo is we can take your logs and actually build out metrics. One way is creating these logs to metrics, and you have to create logs to metrics rules. Using this, you can extract metrics that are embedded in logs. For example, your logs might contain numeric values for latency, bytes sent, request time, and so on. So you can extract multiple metrics from a single log. You can count logs as metrics. For example, you might count the number of log messages that contain 404 status errors. You can use those methods, and kind of the one that's shown here in the screenshot, in combination, you can extract metrics from logs and also count them to create a new metric as well. Again, to get into kind of doing those metrics things though, I would suggest kind of jumping into either some of the other dash or brown bags that we have had regarding metrics, and maybe take some of the training that we offer. Just getting kind of into the logs and metrics again, why we kind of do it and the benefits of it. Creating the metrics out of your logs can help you with performance. Analyzing time series data will always be significantly faster than parsing and querying unstructured data, i.e. logs. With retention, by default, Sumo Logic retains your metrics for 13 months, regardless of your logs retention period for critical business KPIs or long-term operation trending use cases. Ergo, how has my utilization changed over the last 6 months? Metrics will have you covered. It will be also fast to query over these long time ranges, while logs, depending on query and time range, could take some time. And the other benefit is alerting. The real-time metrics alerting engine provides additional flexibility, i.e., critical, warning, threshold, missing data, the typical alerting flexibilities that you have in setting up other alerts. I think there's another chat. Did you answer a question in that? Okay.
Yeah, we're good.
I guess so. What is Kubernetes? Just kind of diving into it. Kubernetes provides a container orchestration system to manage all your microservices. Sorry. It works with Docker and other containerization tools. Kubernetes is open source and a certified member of the Cloud Native Computing Foundation. It scales up and down and works with the cloud-based architecture, including AWS, Google, and Sumo Logic. Kubernetes architecture is ephemeral. In other words, each container and pod and node inside of the cluster can be created or destroyed as needed. Another fun fact, sometimes you might see Kubernetes abbreviated to K8s as the first slide I had in there. It's just the idea that every letter between K and S is 8 letters. So you hear me say K8 throughout this, it's kind of just, I'm tired of trying to mumble through the word Kubernetes over and over. Ingesting data into Sumo Logic we have two ways, the Helm chart and the open telemetry. This one we'll be diving into is more along the Kubernetes Helm chart side of it. We do have a dedicated brown bag for open telemetry as well, which was great, and I'd suggest spending time in that one too. These are our microservices apps, and Kubernetes clusters itself both generate log messages. In order to monitor this data in Sumo Logic Observability solution, you must ingest it and set up data collection. The most common ways to set up Kubernetes data collection in Sumo Logic is with the Helm chart or with open telemetry. Once collected, your data is available in the Sumo UI. We won't cover the setting up the data collection in this brown bag. It's typically a process that is done once by an administrator, and then what we're doing afterwards is kind of setting up the analyzing of it and monitoring. The primary app that we will be working with is the Sumo Logic Kubernetes app that you'll find in our app catalog. The app has many features, the ability to manage and monitor multiple clusters, centralizes data or metadata enrichment, and ensures consistent tagging across logs, metrics, events, and security data. The visibility into worker nodes, clusters, and the ability to explore your cluster's containers, pods, and nodes. It allows you to view the center namespaces, deployment services in your cluster, providing deeper visibility and a different perspective in traditional hardware-centric views. The live and dynamic pre-built dashboards that we offer take advantage of all your logs, metrics, and events, including your security data. All this is built in the Cloud Native Computing Foundation standards and comes with out-of-the-box security features. Let's jump right into it. So I guess I'll clear that out. Well, I guess I won't. So what I did earlier was kind of find out, make sure that the environment does have Kubernetes data. So I kind of just searched a quick keyword for Kubernetes, and depending on how organizations do it, they'll either set up with Kubernetes or K8 or Kubernetes and some other words on it. So I just quickly did a quick search against Kube and found out that we do have Kubernetes coming in on 9 different collectors. And this is our training environment. It's kind of the most built out one I could find for this brown bag. So searching through it, I was able to find that we do have the data coming in. And I would suggest that once you do know that your organization has the data set up, like I said, you kind of go into the app catalog. And from here, you can search Kubernetes, which is already loaded. The Kubernetes apps is the primary app we'll be working with. It is the Kubernetes app. This app's main functionality, features, and benefits include the ability to manage. I'll just open it up. It offers the ability to manage and monitor multiple clusters, the centralized metadata enrichment, visibility into your workloads, clusters, and explorative clusters, containers, pods, and nodes. The views, there are views that allows you to see the center of the namespaces, deployments, and services as well. There's just a plenty of them. And within our apps catalog, before I get too far, there are actually hundreds of Kubernetes apps that we offer. They're all going to be kind of adjacent to Kubernetes themselves. You'll be able to use a lot of what we typically consider them to be on well, I guess these ones are our control plane ones here. Anyone with the KS at the end, the Google, the AWS, which I'm not sure is not showing up. Or the EKS, sorry. Amazon's Kubernetes one. So we have lots of different apps that you can use depending on the use case that you're trying to monitor your Kubernetes. But yeah, so I've already went ahead and installed this one ahead of time. It's just kind of simple steps of just choosing your source category, things like that. From there, you can kind of hop into it and looking in on the app, you're able to see basically this is the different views here. The first view you come across is the node view. You can visualize your cluster hierarchy with the node view. This view lets you drill down into your clusters. I think mostly we'll be looking at the Travel Logic one. This looking at the entire node, you can see the health of it, the usage, disk space, things like that. From there, you can drill down into what is called the deployment view, and the deployment view organizes your cluster into the deployments inside of the namespaces. And it displays the pods and containers used by each deployment. You can use this view to monitor deployment performance and manage necessary changes. The service view is getting into all the different services here. Service view organizes the services inside of the namespace and displays pods and containers used by each service. The view groups all your service pods into one view, making it easier to monitor these ephemeral pods. And back to the namespace as well, it's kind of just is a way to organize your pods and containers in each namespace. One also neat feature that we have for viewing the services that are running is using the services map. So you can open up services and you'll get a list of all your different services that are running. And if you want to see kind of a broken out map of what services are connected to each other, you can actually use the services map view, and it will show you what services are running and how they're connected. Cleaning all that up. Let's get into setting up some metrics monitoring. So open up a metric search. Already have one here actually. So when we're looking at this, you can typically get a list of all of your different metrics that you have currently running. There are, depending on how it's set up, you should begin to get a lot of them. I'm gonna, oh, it actually saved it. I'm gonna look at, actually, we'll look at float D. I want to see the number of errors that are coming in for Fluent D. And I'm going to use a filter for the anything originating from Kubernetes. Time series up. So here you can see many different events that are coming in, different errors for Kubernetes. You can change it to be column views or bar views. I'm gonna leave it at column. And then as someone asked earlier, the different operators that we use, I'm gonna go ahead and just sum it by the pod. So I'll get a count of errors by the pod themselves. From there, we use this kind of dashboard and create many other ones off of lots of different metrics to create different panels, and then add them to dashboards so you can continue monitoring. Let's call it empty errors. And I'm gonna create a new dashboard so I know to clean up the work I did on this one.
Smart.
So here, now we have a dashboard for monitoring your metrics. Another way to monitor it kind of in a proactive way instead of kind of having a dashboard that you're constantly looking at for errors is you can create monitors off your metrics as well. So what I would do is go into monitoring. I guess I should say, one thing to talk about is before troubleshooting a problem, you must become aware of a problem, that a problem exists. So the ideal way is to isolate the problem to discover the root cause. The Explorer tabs, the pre-built dashboards, and custom dashboards can help you monitor your cluster, so you'll be alerted when a problem occurs. You can also use them to explore your cluster and isolate issues, ruling out alternative causes. The monitoring and alerting part of it is a better way to kind of, like I said, get alerted on things that are happening when they happen. So way of setting up is going to monitoring and go ahead and adding a new monitor. And then you're going to select metrics 1 instead. And for this one, I'm going to go ahead and use the same sources that we're using. So go with the fluent errors, go origin equals Kubernetes again. And see if it in the same data. Sum again. And pod. So now we're getting the data that comes in. We want to set up an alert. Let's say critical. It's greater than 50 is kind of high right now. Say greater than 10, why not? Fault test. And we'll say within an hour. So now you should be able to get an alert when an error occurs, when more than 10 errors occur within an hour. It's, usually services kind of flip on and off, and errors kind of come and go. We can set this up as a type, and from there you can create, lots of different types of ways of being alerted via Slack, emails, service tickets as well. I'm gonna go ahead and create an email, and you can add, an email address to it. Here you would add the message to your email body and the recipients to it. Then you kind of create more details. You have to add a monitor name. You just call it fluent errors again. And we're good. Of course, it's not alert. And so I got done here. Critical alert. And done. Have to have it. There we go. So now we're able to see the alerts. It's not alert, not showing up yet. So that's how you kind of create the alert to be notified when anything on the Kubernetes is airing out, or if you have anything for CPU thresholds, different things like that.
And you set that up to be emailed to you, right? Not using a webhook?
Correct. I had it emailed to me. That's correct. Typical common alerts that you would want to probably look into setting up would be things like crash loops. Sometimes your replication service keeps restarting pods in order to maintain a correct number of replicas. When this happens, the affected pod will have a status of loop crash back off. You may want to create an alert anytime a pod has this status, or if more than one pod maintains the status for a period of time. There's quite a few more. Node not ready. If there are insufficient resources allocated to a node, it may have a status not ready or unknown. There are memory limit exceeded alerts you can do. And then you kind of learn to triage after that. It's like if you have the crash loop, you may need to check your services and deployment settings to make sure you have the correct number of pods for the job you want your cluster to perform. And for the nodes not ready, you may need to allocate more resources to your nodes to keep them up and running. And those are the kind of things you can monitor for and kind of be ahead of the game if you start to see those alerts. And that's all I had, Lisa.
That was awesome. Okay, so just to recap, so you went over Kubernetes observability, you went into an actual metric and you created a visualization. You went over a couple examples of monitors. For the visualization, since we have a little bit of extra time, I actually had a customer ask me this week, and if you can't help on the call, that's totally okay. I'm still getting help from a different person, but can you go into the metric? And their question was around they wanted to relabel the x-axis in their chart. They had a bar chart, and the x-axis was source category names, and they wanted to, it was too long, it looked really clunky and weird, and they wanted to just shorten them and make it something better looking, essentially. So one thing I recently learned this morning was display override, or whatever you're doing. What are you doing right now?
Oh, this is actually the axis is there.
Okay.
So you won't be able to change the actual name. Like you said, it was clunky.
Uh-huh.
Um, but you can label the axes, which I don't think is what you're saying. Oops, I could spell axis.
I see. Yeah, no, that's I get how it sounds like I just said that. No, it would be like where the 10, the numbers are at the bottom there. Each of the bars were a source category, and the source category name was underneath each of those, and it was too clunky.
Gotcha. I yeah, I don't think I'm gonna have. I can just display it. So it shows it's not. I don't think these ones are gonna show on mine.
Mm, because his data was probably different, huh?
Hopefully, I'm serious. And you said the naming of these were a bit long. Whoa,
Mm-hmm. Mm-hmm.
that's an interesting one. I don't think I'll be able to help on that one. I think I did remember seeing that message though.
Yeah. I've been asking everyone. That's okay. We'll figure it out today with the customer. I just thought since we're in here, we might as well try and see if we can figure it out together. But
Yeah.
no worries.
Was it a logs to metrics one? Do you know?
I do not know.
Okay.
Does
So
that make a difference?
I do believe there's operators that we can use that can look at the first, like you can regex it to look at the first few bits of a word even. So when you
Mhm.
post category, um maybe metrics names, when you look at source categories and stuff, you should be able to use a regex to just look at like the first few maybe letters or words even.
Okay, yeah, I'll suggest that too. That's a good idea. Thank you.
Cool.
Okay. All right. Well, that was my question. If anyone in the audience has a question, feel free to type it in the chat here and we can have Trent answer it. Again, he covered logs to metrics with Sumo Logic, covered Kubernetes observability. We've done a session on AWS observability in the past, so we wanted to also teach on how Kubernetes observability worked as well. So if there's any questions around anything he's covered, we'd be happy to answer it right now.
You don't have any questions, Maddie?
All right, I think we're good then. Trent, this was amazing. Thank you. I'm excited to get the recording up for everyone to rewatch when they have time. I'll go ahead and stop the recording now.